So, today I want to talk to you about the effects of inbreeding and how it's not really the best for a population. So, before we do that, let's review the concept of natural selection. And natural selection is the idea that a member of a population that has a special genetic trait that's advantageous is more likely to live to an age where they can reproduce and pass on that special trait to their offspring. And you should also remember that a population can get a lot out of having a big gene pool. And the bigger the gene pool, the more genetic diversity the population has, which allows the group to adapt to many different environmental changes. So what is inbreeding exactly? Well, inbreeding is when people in a population will selectively have offspring with a certain smaller group within that larger population. And this can be for a bunch of reasons, like religion or culture, or maybe just because of preference. And when inbreeding occurs with non-human populations, it's almost always due to geographical barriers, where the greater population simply isn't accessible. Now, when people usually think of inbreeding, words like incest come to mind. But inbreeding really isn't limited to members of the same family having offspring together. Lots of small religious and cultural groups in the world have some people with common ancestors and are only distantly related. So you can see that the effects of inbreeding can exist without close relatives actually having children together. So why is inbreeding a problem in the first place? Well, let's look at an example. So Tay-Sachs disease is an autosomal recessive disorder. And what that means is that people with no copies of the genes are unaffected by the disease. And I've drawn these people in blue. People with just one copy of the gene are not affected by the disease, but are carriers for the gene. And I've drawn these people in red. And people with two copies of the gene are affected by the disease, and I've drawn these guys in purple. So let's say we have someone who's a carrier for Tay-Sachs. So he has just one copy of the gene. If we're looking at the general population, we can see that the odds of the person choosing a mate that's also a carrier for the disease are pretty low. And if he eventually has some kids, none of them will be affected by the disease, and only a few will even be carriers. It's likely that the copies of the gene will be so spread out among the population that it would be quite rare for two carriers to actually end up mating together. Now, if we look at an inbred population where a bunch more people could be carriers for the disease, the chances of our guy choosing a mate that's also a carrier are a little higher. So more of his children will be carriers for the disease, but there's also a chance that some of his offspring may get two copies of the gene and actually be affected by the disease. Now, we just talked about an example with an autosomal recessive disorder, but maybe you're wondering how inbreeding affects autosomal dominant disorders. Well, let's look at Huntington's disease, which is autosomal dominant. And since this disease is autosomal dominant, if a person has no copies of the gene, they'll be unaffected by the gene, and I've drawn these people in blue once again. However, if a person has either one or two copies of the gene, then that person will be affected by the disease either way, and I've drawn both of these people in red. The key difference in this case is that no matter who the guy has children with, even if that guy just has one copy of the Huntington's gene, there's still a chance that there will be children affected by the disease. Now, of course, if our guy has children with someone who was also affected by the disease, then more of his children would be affected, but there's still a chance either way. Now, one of the other reasons why we're less concerned about inbreeding affecting autosomal dominant diseases is that carriers for dominant disorders are generally aware that they're affected, and are well aware of the risks of them having diseased children. With recessive disorders, carriers usually don't have any symptoms at all, and they may not even know that they're carriers until they've had a diseased child. And this makes it much more important for people in inbred populations to seek genetic counseling so that they are aware of the risks of them having diseased children. So, what did we learn? Well, first we learned that certain inbred populations can have many more individuals that may carry a diseased chromosome than the general population. But we also learned that this is mostly a concern with autosomal recessive diseases, since those generally go more unnoticed than dominant ones do.